Thanks to Nixi, Chandraprakash sir, Shubham sir, as well as Rajiv sir for providing us with this opportunity to explain and have an interaction on DNS. So today's sessions are like this. Basically, we start with the basics of DNS and then followed by how to configure DNS, how to configure a recursive resolver, what are the kind of attacks which are going to be, which we'll be looking at, and also how do we mitigate them. And then we also look at DNSSEC, we also look at DOH and DOT, and finally we also showcase some of our tools which we have developed in the this thing. So that's the part. So let me, without much of ado, let me start this session. The domain name, basically, when we talk about domain name, it starts with the protocol, and then we have the actual domain name and followed by the resource or the path of this thing. So we are not keen on the right-hand side, that is basically this particular part, the path of it, or the protocol part of it. We are primarily focused on the domain name as such. So how do we going to look at that and these things? Because this is going to be talking about the internal application path within the server. And while this talks about the protocol, which is most likely it is going to be HTTP or HTTPS. Of course, there are other protocols also, but that are not part of our today's focus. We'll be primarily focusing on this particular part. So then when we talk about a domain name like this, that is, let us say coednssecurity.in, it actually translates to an IP address. Okay, so something like 220.156.189.66, which is an IPv4 address. So what actually happens behind the scenes is what I'm trying to explain in the next couple of moments. When you type coednssecurity.in in your browser, so what happens is basically what actually you're typing it is in a browser. So basically it belongs to the application layer of the protocol stack that we talk about. So this query, first of all, let us say as you type https coednssecurity.in, immediately your connection has to be established to the server. You may be anywhere in this world, but a connection from your machine, whether it may be mobile or your laptop or desktop, whatever it may be, from there connection has to be established to this particular server. So that is the challenge. And basically this server is, meaning once we have a connection established to this particular server, but first of all, how do we establish the connection to the server? How do we connect it? Because coednssecurity word as such cannot directly connect it to you. So we need a machine understandable IPv4 address for this particular thing. So that is where all the communication actually comes into picture. So if you look at it, the communication actually percolates down to the next layer in your software stack, which is called the transport layer, where the query will be constructed. Basically, the port number and the destination port. Basically, when you talk about HTTP, it is 80, and HTTPS, it will be 443. This will be constructed, and then basically this is it further goes down to the IP layer, that is network layer we say. This network layer will be in your system, will be the same as that is in the router also. So there, what happens is we need to construct the query with the source IP address as this one, and the destination IP, we need to figure out what is the IP address of coednssecurity.in. So that is the point. So here, this destination IP is basically where we need to find out what is the IP address of that particular domain name. So from there, network layer, actually, we further go down to the data link layer, that will be the switch level. Once you figured out the IP address, then you further go to the switch level, and then actually it gets connected to the switch in the server, particular server in CODNS security server. So here, if you look at what actually happens in from a desktop or a laptop is, as imagining the left hand side is your laptop, the query actually transcends layer by layer beneath the application layer to transport layer to network layer, and finally we need the logical address. Basically every device we need to have a network address will be there in the line. Basically this should be a unique one also. So this actually will be going through the router, and from the router we get connected to that. And finally the actual connection happens through the physical cable, that is basically a data link layer, where it gets connected to the MAC address of the machine. So once let us assume that this machine and this router, if you can consider as part of your own network or your own operator, whether if you are using at home, maybe this router can be your Wi-Fi router from any operator like Jio or Airtel or BSNL, it can be. And from there, it actually gets connected to the router, meaning it actually goes through a number of interconnected routers. So after it finally reaches the destination router, so where it can finally directly communicate with that particular machine. So this is what actually the external world actually can happen. So now, depending on where you are and depending on the server where you are, actually this interconnections can be across the globe. It cannot be, meaning it's not as simple as shown in this figure. It can be probably like this also. Suppose if the you are in US and we actually this server is hosted in India, then all the connection actually has to traverse through the entire world through undersea cables, and then finally lands up in the switch and the router at our location. So this is basically the connections and communications which can happen. So that's the point which is actually happening. So then basically what this DNS going to do is it's going to translate the domain name to IP addresses. That's what we are going to trying to refocus ourselves. It can be an IPv4 address or an IPv6 address. And most of you would also know that it can do the reverse translation. That is from IP address to back to domain name. And again from IPv6, meaning basically it can actually get retranslated into IPv6 address to domain name. So that's the thing. So now with this basic understanding of what happens as we type a piece of domain name in the browser and how it traverses through multiple layers in the protocol stack, and finally it reaches the destined destination machine and IP addresses. Now let us look at how do we parse the URL, or how we look at the URL. So for example, when there is a domain name like this, as I said, our focus is more on the domain name, not on the protocol part or the file path, which is going to be there. COEDNS security.in is basically the domain name. So there, this particular dot, meaning first we need to have an imaginary dot at the end of the particular domain name. So that's where we start. And we start reading from the right hand side. So this imaginary dot, why I wanted to put is, this actually refers to the root server. Okay, so root server is what we are going to discuss in the next couple of slides. But right now, imagine that is the top or root of the hierarchy. And then .in refers to the TLD domain, that is a top level domain. And COEDNS security refers to the second level domain. So this is how we typically, it's better to read a domain name from the right, assuming an imaginary dot at the end. So this particular gray dot, which actually will not be there, but there's an imaginary thing which you can assume. So this refers to the root, and in refers to the country level top TLD domain, that is CCTLD, and followed that we have the actual second level domain name, which is basically COEDNS security.in. So as we put up the structure of the DNS, so you start with, as you can see that there are multiple, look at the root server and follow that in is there, org is there, net is there, com is there. and then COIDNS security, google.com, facebook.com, ac.in, everything is there, second level domains, and further subdomain and host names are there. So, so what actually happens here is, when you, for example, if you look at facebook.com, you can see that we traverse from the root server, and then basically, meaning the root from the, meaning actually every one has its own control. Say, for example, let us say, for example, .com. Under .com, I can have facebook.com and I can have google.com, but I cannot have another facebook.com. That is not possible. But I can have facebook.net. Okay, though legally it is not allowed, but I'm talking much on technically. So basically, I can have facebook.net, I can have facebook.org, I can even have facebook.in. That is perfectly allowed and permissible. Okay, but of course, the copyright owner has to agree for that. But other than that, if you look at technically, it is allowed actually. But I cannot have same name. So under the .com domain, I cannot have multiple facebook.coms, or I cannot have multiple google.coms. That is not allowed or permissible. That's the point. So then below that, we have facebook.com, and meaning again Facebook. Now what happens is, after the facebook.com, it comes under the control of facebook.com. So they can have any number of domains below them. So for example, if you look at COIDNS security.in, it comes under .in domain. Okay, so we have basically, but meaning what I can say, leased this particular domain name COIDNS security.in under the .ins. So basically, under COIDNS security, I can create any number of subdomains. Say for example, dwayth.coidnssecurity.in, tools.coidnssecurity.in, research.coidnssecurity.in, etc. So I can create any number of subdomains under that. It is under my own purview and control. Now, what we call is, basically these are namespaces. If you look at from a slightly logical viewpoint, these are basically namespaces. So under the .in domain, the namespace actually, meaning this particular entire, meaning this particular stretch ac.in and coidness actually falls under the .in namespace, while dwayth.coidness.in or tools.coidnssecurity.in falls under the coidnssecurity.in namespace. So that is the point. So what happens is, similarly, you can have, for example, if you look at google.com, you have meaning so many things falling under them. Maybe mail.google.com, or maybe documents, docs.google.com, etc. Multiple subdomains can be there. So it falls under their particular namespace. So who manages the namespace for this one? Mail.google.com. It is managed by Google. And who manages this particular namespace, this google.com, facebook.com, that namespace manager is basically com. And who is the namespace manager for this entire stretch, .in, .org, .net, .com? This is basically the root name server. Basically, that is basically dot thing. So there is a question, I think. So I think, let me check if there is any question. A member has raised their hand. I'm not sure how do I allow you to, talk. Maybe you can type in the question, Mr. Anandaraj, and one more person I think had raised their hand. I think they wanted to say something. If yes, please, you may please type in the message. So I'm not sure whether I'll be able to allow you to unmute you. Mr. Anandraj, I'm not able to actually unmute you, but I think you can, if you have a question, please put it up. Definitely, we can answer that. And the other person also, I guess he was Mr. Rakesh. Yeah, thank you. I think already I've got started getting the questions on the chat window. Let me start answering them. Yeah. Okay. The first question is basically who is responsible for the root server? Obviously, that's where I am about to come to that particular point. So basically, root server is managed by ICANN, and there are basically technically they are the people, but of course they have outsourced their activity to other organizations who manage them on their behalf. So we will come to that little more detail in a moment of time, and then. nitk.ac.in is part of the second level domain, I understand. Yes, absolutely. It is NITK is basically under the ac.in. So that is the thing. It is been there. No. I mean to say, sorry, actually what I meant to say was basically when you have added a www, basically that is a kind of, meaning you can have multiple folders. Say, for example, I can simply say facebook.com. Similarly, you can actually create a www folder. So since facebook.com is a web application, they typically people want to use www dot also. So there is a folder which is created under that. So even if you type www.facebook.com or facebook.com, you should be able to reach to that particular domain name. So what they do is, it's not actually a subdomain or this thing, but what they do is they create a alias kind of thing. So which actually looks like a subdomain to you, but actually it's an alias part where there is a folder which is created, www. Under that folder, the web pages are loaded. So anything can be actually looked at this thing. So you can reach both facebook.com and www.facebook.com through the same way, which is actually there. So under, meaning I just showed an example here, it can be multiple subdomains also. This is just an illustration which has been told here. CAN is responsible for root server. I don't know what is CAN. Maybe that's probably ICANN is actually, I think maybe it's a misspelled one. ICANN is actually responsible for root server. Can we set up root DNS server in our network? Yeah, very much possible. You can set up meaning basically a sample thing, but you will not be able to connect to the internet. So it can be a emulation thing you can do. In fact, we have emulated the entire hierarchy from the root DNS server as well as TLD as well as STLD in this one in our lab here. So to test the queries, latencies, and all those things. So basically, you can definitely do it in your lab, in your network, you can emulate it. But of course, you will not be able to connect to the global world. That is different. So this network has to be separate, and it is definitely possible. Should not ICANN be responsible for root server? Yes, they are responsible. I think there was some miscommunication which had happened. Yes, ICANN is responsible for, yeah, there is already an answer which has come. Basically, canonical name, that is CNAME, which is actually called www. Yeah, so that's already given. It's ICANN. Yeah. Yeah, there is another interesting question. Does the root zone contain all the DNS data? That's a very important question also. My next slide is going to give the answer to that. Answer is no. It does not contain all the DNS data. So just I'll pause here for a moment. I'll go to the next slide, and then you can actually understand. So here, basically what we are talking about is, here there is going to be a manager, or we're going to be a meaning entity which is going to be responsible for the namespace, which is going to manage the domain names under that particular level, and it follows a tree structure. And this is a critical component of the internet infrastructure. So this is where the distributedness comes into picture. So what I mean by distributedness is, say for example, see, root is responsible only for its immediate next down level, next step. Say ICANN is basically responsible of managing .in, .org, .net, and .com. So it has only that particular data within it. Okay, it does not have all of the data within it. Okay, so for example, .in is having only the data which is, say for example, here in this, as per this image, only ac.in and coidnssecurity.in, and not about google.com or facebook.com. They do not manage them. Similarly, .com is managing only google.com or facebook.com, which is actually under their namespace. they are not actually looking at COIDNSSecurity.in or AC.in. They do not have that particular data. So here basically whoever is responsible for that particular namespace, they are to manage the data. So my data will not be, say for example, whatever, say for example, dwaith.coidnssecurity.in or tools.coidns.in, which I have created, will not be available under .in. Okay, so .in does not have, meaning .in does not have the information about what are the DNS data, which may be A records, or meaning we'll talk about records little later. So A records or MX records, whatever it is about dwaith.coidnss.in or tools.coidnssecurity.in under .in. That is not there. Only within that. So for example, if we are talking about .in, we are talking about AC.in or coidnssecurity.in. Those particular domain names and those particular things will be there. So that will be actually under the .in domain. So that is the part. So then, so basically, as I said that root zone will not contain this thing. This is where the distributedness comes into picture. I am responsible for my namespace. .in is responsible for its own namespace, and the root server is responsible for root namespace. So indirectly, we are under the hierarchy of root, but we are the managers for our own namespaces. Okay, for example, .org, there is a separate operator who will be responsible for that. .com is also separately managed. So similarly, there is for every namespace, there is a separate owner, and they will take care of the particular management process. If so what exactly is ICANN? I think ICANN ICANN is a not-for-profit organization which has a very long history, basically. So basically, they are being responsible for assigning names and numbers in the internet. So when I say names, it is basically domain names. When we talk about numbers, they are actually talking about the IP addresses. So so ICANN is the organization which actually what I can say manages thing, or maybe which I can say which is basically coordinates and manages, is what they're saying. So there is a lot of CCTLD domains. For example, .in, like .in, every country in the world is having a 2-letter code for their particular domain name, which is managed by that particular country. So that is the thing. So and of course, the domain names under .in will be is being managed by NIXI, NIXI for this particular thing. So this is how it actually works. So that is one thing. So yeah, already there is a description which is given. ICANN, and if I set up a root DNS server in public IP address, will it help in better and faster resolution of domain? First of all, let us say that you are having a root DNS server. Nobody will be able to access your root DNS server. That's the answer. Why? Because the it's a very interesting question and important question also for everybody to understand here. So for example, when you look at this particular the root name server, it has a fixed number of servers to whom it will access to. Okay, it will access a fixed number of servers. It is basically 13 root name servers are there. It will only look at 13 root name servers under it. Okay, so the 13 root name servers are named as A, B, C, D, F, G, H, I, J, K, L, and M. Okay, so these are the 13 root name servers which are there. So the root, when we talk about root name server, we are only talking about these 13 root name servers, okay, which are at the top level. So your root name server, even if you set up in public IP address, nobody will be able to, meaning nobody will come to you, because the resolution process, query resolution process, is designed in such a way that you always go to the root name server only. So please hold Mr. Amaya for a few minutes. I will just clarify the query resolution process in the next few slides. So I'll also just go to the next few slides also. Okay, what about domain names like online SBI.SBI? Yeah, that's an interesting thing. So ICANN, what they did was, apart from these country level domains, CCTLD domains, and older domains like .com, .net, .org, they also started giving away certain generic TLDs. Okay, we call as generic top level domains. So they, so wherein at that point of time, organizations like SBI applied for their own domain name like .sbi. Okay, so they actually applied for it, and so that they will have more stronger brand identity and visibility. So they applied for that. So similarly, there are many organizations which have done applied and got generic top level domains, including Reliance and Airtel in India. So these are some domains which actually been managed. So .sbi is a domain name which actually is under the root, okay, but it is not under IN, okay, it is under the root, and it is being managed by SBI. Okay, SBI is State Bank of India is responsible for that management of that particular domain. Okay, one more question. How does a new DNS server IP address is updated to all the nodes in the network? Okay, so for example, I think this question will, it will become clear once we understand the query resolution process. Okay, so it is a very interesting process because basically it all happens, how the resolution happens and how caching happens. So that if you understand, then automatically the answer will be clear. Just hold on it for a few more minutes of time. The next question is about how domain sellers coordinate while selling domain names. Okay, so that is nothing but actually if there is basically a reseller, I think you are talking about, or maybe basically, okay, even if you are talking about a seller, so if you want to buy a domain name, I'll talk from the buyer's perspective. I want to buy a domain name, and if it is not having any issues, and actually I just go to whatever domain name and they see whether that particular domain name exists or not, and based on that they give me some suggestions, and I take up the suggestion and buy the domain name, and of course I pay the money. So then how the resolution process, I think once again will clarify that to you, how that resolution happens. So let me proceed with the next few slides so that it becomes clear. So as I mentioned that this is a DNS actually provides a consistent hierarchical namespace for referring to resources, and nodes at the same level cannot have same names, and it is a tree structure. That's exactly is what we are discussing about now. So this is basically a globally distributed, scalable, and reliable database. Now, this is a decentralized, I think audio is coming for others. If someone is having audio issue, I think maybe
yes, there is no issue in audio.
Yeah,
voice is very clear.
Thank you. So basically we are talking about a decentralized naming system. What do we mean by decentralized naming system is, I'll again come to this particular slide. What do we mean by decentralized naming system is I can keep any name here under COE DNS security.in. Nobody will question me. Say for example, I can keep Balaji at COE DNS security.in. Okay. I can keep abcd.coe DNS security.in. Okay. So that is decentralized. I have. So who is responsible for keeping it? Of course, COE DNS security.in is responsible for it. Now let us say that you also want to create another domain name with the same name as COE DNS security.in. Then .in will have a problem because it is the manager of that particular namespace. It will say you are already conflicting with the guy who is already having COE DNS security.in. So you are not allowed. So that is the thing. So this is the kind of decentralization which it happens here. Okay. So you are responsible for your namespace. You are free to create any number of subdomains in the way which you want. Okay. And DNS administration is shared. Okay. That is, it's not that the root DNS server is managing all the records and all the DNS data, everything which you are seeing today. No. Everyone is responsible for their own namespace. So I am responsible. If I am created a, let us say, tools.coe.security.in domain, I have to ensure that it is reachable, it is having a proper IP address, it is having the proper A record, everything, and I have to ensure that it is reachable. Okay, either .in or the root servers, they will not be interested or they will not be keen to, they will not be looking at whether I have done this properly or not. So this is the thing. There is no, because they also don't know also. There's no single entity which contains all of the data, administration data. That's the point. And this distribution of this thing is called delegation, because you are delegating it to the sub entities there. And further, what happens is the root matters more. Why root matters more is the DNS client, let us say that for example, I am asking for an IP address of coednssecurity.in for a DNS resolver, and what happens is, say for example, let us say that it reaches the DNS recursive resolver. So the resolver, let us say it does not have the IP address. If it has not cached the IP address within itself, then what happens is the next step is it will send a query to the root name server. So root name servers, I said there are 13 root name servers, which is starting from A, B, C, D, F, G, H, I, J, K, L, M. Okay, so it will reach any one of the root name server which is nearer to them. Okay, typically there will be 3 to maybe 2 to 3 root name servers which are nearer or which are closer to a particular region. So it will send that particular query asking for, that's where you have to looking at it. So it will say that it will please provide me the IP address for coednssecurity.in to the root name server. Let us say it sends it to, let us say A root server, etc. So now A root server will say that, am I not really audible? I hope. Am I audible? Yeah, thank you. Yeah. So what happens here is the resolver actually sends the query to the root name server, let us say A root name server, and asking for the IP address for coednssecurity.in. Now the root server will say that I only know the IP address for .in. Okay, you go and ask the .in name server. That's what it is going to tell. So now the root name server, that is A root name server or B, C, D, F, all these 13 root name servers, and please, I just want to tell one more interesting information. All these root name servers A, B, C, D, E, F, G, H, I, J, K, L, M all contain the same data. They are absolutely equal. Nobody is bigger or smaller. What I mean to say is, it's not that A is bigger or C or A is smaller, nothing like that. All are equal. All have the same data. Only thing is, these A to M root name servers, each one is having a different meaning different operator or a manager. Okay, so the content is same, but the infrastructure management is done by different agencies. So that is the point. Otherwise, the data is totally shared. Okay, it is all common. There is no this thing is an exact copy. Whatever is there in A root server is exactly in M root server also. Whatever is exactly in M root server, it is there in L root server also. It is there in C also. It is there in B also. So that is one point which you need to understand. Now, yeah, that's an interesting question, Vinod. I will come to that. Just give me a few minutes. Let me finish this particular process of resolution, and then definitely I'll take up all these questions. So now what happens is, A root server will say that I do not know the IP address of coednssecurity.in. It will say that please go and ask the .in name server, because .in name server is the, and because you are saying something which is under .in, so you go and ask .in name server. So that's what it actually says. So now here what happens is, so now further the resolver, the resolver will say that now the resolver will go and ask the .in name server, saying that, asking that please provide me the name server for coednssecurity.in. Okay, so that is what happens. Please listen carefully here, this point. Now what it will say is, .in name server will give the IP address of the name server. Please remember, .in name server will give the IP address of the name server responsible for the coednssecurity.in, responsible for answering the queries for coednssecurity.in. Okay, it does not give the IP address for coednssecurity.in. It only says that who is the person responsible for coednssecurity.in, that particular name server's IP address it will give. So now the DNS resolver will go to the coednssecurity.in name server, and it will ask for the IP address for coednssecurity.in name server, and then it will actually give the it will give the IP address, and then the IP address is further passed from DNS resolver to declined. Okay, so this is the process which actually happens. So here, as you can see, whenever there is no IP address for a given domain name, the resolver tries to send the query to the root name server. Okay, the root name server will then send it to the next domain, which it will actually pass it. It will ask him. It will the root name server will reply saying that you please ask the name server responsible. You ask the name server responsible for the next level domain name. Similarly, it keeps going on. Okay, so this is how it actually happens. So in this case, what happened was the COE-DNS security.in here basically what happens was this the root name server told that you go and ask the .in name server. .in name server told if you go and ask a specific name server for COE-DNS security.in, it will tell you the IP address. So then I went and asked the COE-DNS security.in name server, which gave me the actual IP address, and that is where it actually happened. So now I will stop here and I will look at your questions and then let me try to answer them. Yeah. So I think someone was asking for PPT. That PPT will be definitely available after this session. Okay, I think there is some question. How does own ISP DNS server reduces latency other than DNS of class A ISP of Airtel? I'm not very clear about this particular query. I assume that you are asking, I'm not very sure actually what you are referring to, whether the latency in resolution you are talking about, that has a large number of parameters to be considered. So maybe there are root servers which are provided by service providers like Airtel, Geo, and also Google also. If you look at 8.8.8, it will have its own server. And if you look at our organization, we have our own resolver. So it depends on where the location and how fast it is and things like that, how customized and optimized you are. So one of the session today is we will be discussing how to have effective resolution or how to have optimized resolution of queries in the next session. That's one of the session here. So I will not go more into that. And okay, why only 13 servers? Why are you limiting to 13 servers only? Okay, this is a traditional thing. When the DNS started, they don't want the DNS packet to be fermented. Sorry, they don't want, not fermented, sorry. They don't want the fragmented. They don't want the DNS packet to be fragmented. So they wanted it to keep all the data, that all the A, B, C, D, F, G, H, I, J, K, L, M. They wanted all the 13 root servers to be kept in single packet, single IP packet. Okay, so there was a size restriction at that time. And moreover, what happened was these name servers are actually not named as A, B, C, D, E, etc. Every name server was having some name or the other name. Okay, something just not actually. This was A root server, B root server, C root server that we are talking today. This was given much later. Okay, so this was the conditions. So because of that, the size restriction, and because they don't want the DNS packet to be fragmented, they decided that they will keep the limit of 13 so that it fits well within the thing. Actually speaking, you can go little bit one more also. 14 root servers are also possible, but 13 was limited, and further to several reasons, including geopolitical reasons, actually it was not expanded. So this was the case. Who ensures they are in sync? Okay, that's a good question. So there is something called as RSAC, and there is also several root server management committees which ensure that the data which is being actually you all know that ICANN is the responsible for managing and the root server. So the data will be actually synced from all the root servers. So that A2 thing, it is actually being taken care by ICANN, meaning the responsibility falls entirely on them. Of course, ICANN has outsourced that responsibility to another organization, another company. So they are doing that, but it is all in sync. And of course, there are several monitoring committees like RSAC committee and things like that. So they also look at it, how it is being done. So synchronization is, yes, that's done. How many roots name servers can create? No, we cannot create any root name server. It is already existing and that is there. Is the browser a DNS resolver? Unfortunately, no. Browser is simply a browser. Browser will communicate with a resolver. A resolver is a separate system, separate piece of software, which actually tries to find out the IP address for your given domain name. Okay, so the resolver, this particular DNS resolver, whatever we are showing here, it can be either being provided by your service provider like Airtel, if you are taking service, or BSNL, or it can be provided by a third party also like Google. Google is having its own thing, or even Cloudflare. Cloudflare is having 1.1.1, Google is having 8.8.8. So that is the thing. DNS proxy is different. That is basically it is basically sandwiched between these two servers to translate the thing. Okay, so what is the difference between the DNS server and name server? See, DNS server and name server, what we actually, meaning some of them don't want to use the word name server, so they use it interchangeably. So when we talk about DNS server, we typically refer to the name server only. But to be very precise, if you are supposed to use only precise language, then DNS name server is basically the right word. And for example, the resolver is the right word here. And similarly, here root name servers are the right words here. So these actually form the ecosystem here. What is the if both are needed, if you are creating own DNS servers? No. Actually, that's what I said. DNS name server is the important thing. Okay, name servers are this one, which actually are responsible for managing the particular namespace. Okay, name server are the servers which manage the namespace for that. Okay, for example, .in name means for the name server means this particular server manages the namespace for .in. Okay. Similarly, when I'm talking about COI security.in namespace, then this particular name server manages the namespace under all the domains under this particular namespace, COI security.in. Okay, so this is different. DNS resolver is also a server. Okay, DNS resolver is also a server. That also we call it as, particularly because it responds to queries, because DNS client actually accesses only server resolvers and resolvers to do it. So if you have to use precise language, obviously, yes, you have to tell whether it is a resolver or a name server, what you are talking about. But in the general common man's language, people use very interchangeably. So they typically, when they say DNS server, they typically refer to name server. Okay, so that is the thing. But to be precise, this is a precise language which has to be used. Few DNS resolvers from 8.8, but not able to resolve in our DNS. So it might be restricted. So that you have to check with your ISP or the service provider. Is it important to create self DNS? No, not really. Self DNS is not required. You can actually use the existing systems which are well trusted and tested also. What is the industry standard response? Yeah, that depends on a few microseconds to milliseconds to, I mean, it can go actually. So depends on the location, depends on the where you are querying and things like that. Okay, so typically we measure in milliseconds. Okay, so in the later sessions we can show you also. So that is the thing. What is proxy DNS drop the packet? If it is configured to drop, yes, it can drop. Is DNS server store any cache? Yes, this DNS resolver. I hope here I am assuming for the question of Rajendran Singh, I am assuming, so yes, mentioned as DNS server. So I am also a bit confused, but I assume that he is talking about DNS resolver. Yes, DNS resolver has a cache. Okay, it has a cache. So it will have, meaning it will provide what is the IP address. See, now second query comes. Again, another client is asking for the same particular domain name. It will only give this particular IP address. Nothing will happen. Okay, so that is a part. So that's the point. And but of course, name servers will not maintain any cache. Only the DNS resolver will maintain the cache. And now your browser, once you have got the thing, your client also will have its own cache. Okay, so it will have its own cache. That's the thing. Where store the DNS record for a domain? Yeah, the DNS records for a domain are stored in the name servers. Okay, the DNS records are stored in the name servers. So that is a point here. So that is there. What is the what is DNS based security? Okay, that there are you assume, basically DNS is a protocol. Okay, and that's an application layer protocol. So we are talking about, what are the kind of attacks can happen in this scenario. So this is a resolution process. This is very important, whatever I'm just showing in this particular slide. So there are possible leakages. That can be something which can happen. Attacks can happen. So how this system can be exploited by others, that also we'll be discussing. So we are talking about the security of this entire ecosystem. So that's what we are going to be there. Okay, dynamic DNS is different, that we will discuss in the later part of the session. My colleague, Mr. Gopinath, will be covering that. Okay, how big is the cache store? Okay, so that again is a configurable item. So how much you want to configure, how long you want to configure, and how you want to renew that. So that is basically a configurable thing. Again, that will be covered in the next session. Which root name server to be selected is decided based on latency only. Typically, there will be in the DNS configuration file, there will be 3 to 4 root name servers which will be there, and based on the latency, it is being decided. So which actually goes faster. So the query will pass it to the root name servers, and which will be decided actually. Can DNS hide the IP address? No, DNS cannot hide the IP address. Basically, what I can say is DNS is a human, what you can say, the domain name is basically human readable and human friendly thing, while IP address is machine friendly thing. So it's only a translation between these two. So there is no concept of hiding here. If anyone wants to find out what is IP address behind coidnssecurity.in, they can easily just today they can just Google it and they can be able to get it. Okay, so I think I've answered a number of questions. So let me proceed to the next few slides. So here, what we are seeing is this is the DNS ecosystem that we are talking about here. So we have the clients, whether it can be laptop, desktop, mobile phone, everything. It goes to the recursive resolver here. And as I said, that there is a cache memory which is kept within the recursive resolver also here. So this is what is there. And this resolver, what happens is the client can actually send what I can say, the query request for resolution of a domain name to the recursive resolver, and the recursive resolver will go and first ask the root name server. Then after that, it will go to and ask the authoritative name server for the TLDs. I'm just using a new vocabulary here, authoritative, which means when example, if in the previous slide, if you look at .in name server. So .in is basically .in name server is the authoritative name server for this particular .in namespace. Similarly, coidnssecurity.in is the authoritative name server for this particular namespace. So that is a point here. So the recursive resolver will send the queries to the root name server, which will again then refer to the authoritative name server's TLD, and finally it will go to the authoritative numbers, second level domain and third level domain, etc. Finally, till the answer is obtained by it. So here, typically speaking, we use the word authoritative. Okay, so authoritative name server here, that is the actual word, not even name server. And then recursive resolver, basically this is the because it is recursive. Okay, this is actual word, actual terminology which has to be used, because it is actually going to name server and then further coming to authoritative name server. Till it gets the response, it will not come back to the client. So that is, it recursively finds until it gets the answers, it does not rest actually. So that is the thing. So client or stub resolver is nothing but a small program which will be running in your system or in your browser, which will query this particular recursive resolver. Okay, this will actually be querying the recursive resolver, finding out what is the basically what is the meaning what is it will ask it. Okay, so basically the client will ask what is my what is the IP address for coidnsecurity.in. So that again this is also a query response. So this query has to come originate from this particular server. So there's a small piece of program which actually sits here, which queries the recursive resolver. And then this particular client also can cache the result. So once it cached, it does not have to meaning again fetch it. So it can actually internally do the resolution. Only if it is failing and unable to reach it, then it will actually send it again the query to the recursive resolver. So this is what it happens. So this is how the domains happen. Meaning this is the statistical domain count, the registered domains and the TLDs and GTLDs. Maybe slightly couple of increases will be there. This is almost 6 months old data, but still there will be more or less the number of domains are there. So this is the thing. So what we are talking about several millions of domains. So that's what I want to say. So this is a very big space here. So that's the thing. So I have a couple of questions. So you have been asking me questions. Which querying method is best, recursive or iterative? So from a client point of view, recursive is best. Give me the answer. Okay, so that is recursive. Okay, iterative, basically what happens is, see, from this particular point, the root name servers or authoritative name servers, they will say that you ask me a question, I give you an answer. That's it. Don't come back to me. If you're satisfied, you can take it, or you can actually go to the next thing. So that is basically this thing. So here what happens is the recursive resolver has to iterate across several name servers, root name server, authoritative name server of SLD, etc. And then that is happens. So that is the thing. From its viewpoint, it is basically, it has to do iteratively, it has to query and it has to process it. That's the thing. Any alert system is an attacker is trying to hack. No, that's a challenge. That is where we have to look at some of the methods which will be looking at it. And I don't think IP address you type on the browser. I'm not very clear what actually was response to. Okay, so can you access internet without the? Yeah, okay. I think you are trying to answer this question. Thank you. That's a good answer actually. Can you access? Very good answer from Mr. Vijay Bhushan as well as Tushar and everyone actually are now started typing. Yes, you can access internet without a DNS, but you need to have the IP address. So if you have the IP address, definitely yes, and you'll be able to directly connect to that. Can the DNS give you wrong answers? Is there a possibility? Ideally, we expect right answers, but unfortunately, it can give wrong answers if it has been poisoned. Yeah, thank you. So, so what happened is if it had been poisoned, that cache has been poisoned, then it is actually there. If the DNS is poisoned, not poisoned, then how do you land up? Maybe you may be asking me a question. The DNS is perfectly fine. Then still how I land up in some wrong or fake web pages? This is a question. So very interesting question. So this is where the answer is people trick you. Okay. So how the tricks happens? And all these things are called abuse of the DNS system. Okay, all these things are called as abuse of the DNS system. So some of the common exploits, just we are going to share it just for a few moments to update it. So I receive a message here. I think this domain belongs to SBI because the word SBI is there. Okay, so I actually click on it and I land it here also, and the page is similar to my banking web page. There is a, but if you look at the URL, it is something else. Okay. Of course, this currently, this whatever example you are seeing has been completely banned and it is being cleared off. Okay. This is a slightly older example which I'm using. It was a couple of maybe a year old example. So these kind of ways in which people can be tricked. Okay. Emails can come, SMS can come, WhatsApp can come. You click it and you believe that particular thing is there. Now I have another interesting question. Do you trust this mail? I got this mail. Yeah, social engineering also is a kind of attack. Okay, most of the people say no, but ideally what we did was when we checked this, the mail was genuine. It was having no issue because again, as I said, we need to read the domain name from the right. So com Adobe. So Adobe generally, you know that it's one of the good companies, and meaning with the good products and things like that. So campaign.adobe.com, which means that so campaign is a subdomain which is being created on adobe.com, and then there is something called CNAME canonical name which is being created under campaign, and com, it actually com, and then below that, meaning again there is something called com, and then Elsevier, email, then Cellpress. So basically this is about a journal called Cellpress from Elsevier. They have tied up with Adobe for running a campaign for promoting this particular thing to their customers. So, so this is where the things go little tricky. So when you look at long domain names, generally we suspect and we don't believe that. But here, this was a genuine case basically. So what I mean to say is this takes a lot of effort to find out. But this is one of the rare cases which is genuine. Okay, so generally it is it's going to be quite tricky, or it's not going to be easy to believe. And then there is something called as puny code. Okay, so puny code is something like you have, let us say, a common domain like apple.com. There are certain characters which can be, say in English, which can be represented in multiple ways in different other languages. So for example, apple.com with the apostrophe at the top, or L at the dot, or E at this thing, they all can, what I can say, the slightly created variants of this particular domain name. Okay, so these are certain interesting things actually. Apple would have themselves registered to protect their customers this thing. So these are some of the domains which are there. These are all Unicode representations on the left hand side for the characters for that particular domain name. So this is the thing. So one needs to be careful on this particular domain names also. So I just want to tell you what kind of attacks we can see here. One is we can classify the attacks on the DNS ecosystem as two types. One is basically attacks on DNS infrastructure. Okay, so basically someone, let us say that shuts down your recursive resolver, then you will not be able to query this thing. Okay, so that is something cannot be done. Okay, meaning then you will not be able to query. So what you do is automatically, that's why what happens is whenever the ISPs generally they configure multiple name servers. If one root server fails, another one comes into picture. So that is how it actually happens. Then another one is basically, the second part is the attacks which are exploiting the DNS infrastructure. Okay, which are exploiting the DNS infrastructure. What you are talking about is basically there is a huge canvas of attacks which are possible. So we know that this is how the querying happens. This is how the resolution, DNS resolution happens. So what kind of attacks are possible? Huge canvas of attacks. Phishing attacks are possible. DDoS attacks are possible. Ransomware attacks are possible. Botnets are possible. Malware is possible. So these kind of attacks are possible. Detection is easier, but prevention or taking an action on attack is a challenge. Okay, so this one we will look at it in detail today's session. Okay, how the infrastructure of this thing. Say for example, I keep sending multiple queries to DNS recursive resolver. Okay, I will bombard it with multiple queries from multiple clients. Then actually the recursive resolver will be down. Okay, so then what happens is, this is whatever I just now told you is actually an amplification attack. Okay, DNS amplification attack. So this is possible. Your entire DNS ecosystem can be converted as a botnet, okay, and can be turned into an attacks thing. So this is something which everyone has to collaboratively work upon. So some solutions are there which are meaning what you can say is which are not 100% foolproof. It is basically kind of solutions which can help you to protect to a large extent. One is securing the infrastructure through configuration, secure configuration, signatures, keys, devices, DNSSEC, etc. Then again, another thing is by creating awareness on conscious actions by users. These are certain things which can be done. So this is how it can be done. So here I want to categorize the kind of attacks which we can see in the DNS ecosystem. One is which directly attack the DNS infrastructure, which is very rare. Another one is basically which exploit the DNS infrastructure. Okay, so that is the part which exploit the DNS infrastructure. So that is it. Then finally, before I conclude, I just want to tell you that domain names need not be in English. It can be in local languages also. Indian languages domains are also possible. Okay, like cdag.bharat, written in Hindi, written in Kannada, and email addresses also can be like this, like my own this thing. It is possible. It is there. And for creating awareness, there is an Universal Acceptance Day which is being celebrated on 28th of March every year. So that is also there. So with that, I would like to, just coming to my end of the presentation, there is a lot of resources which are available in coednssecurity.in website. And there is also a YouTube channel specifically called INRIN, where you can see some of the videos and all the contents which are there. So with that, just give me a couple of minutes. I will stop sharing this. So trying to share now. I'm not sure whether okay. I hope are you able to see this particular website, coednssecurity.in. In case if you find any malicious domain, you can share it with us, and it will go as part of our database, and we will forward it to the right authorities. And similarly, if there is any spam email which we are actually trying to create a data set and try to do AI-based learning for this particular thing. So this also can be done. Any spams you can actually look at and send to it. So that is one thing. Then if your example, apple.com, meaning this is a tool which is available under tools, several tools are available. You can actually go to Punycode Converter to type apple.com. You get the list of things which are available as Punycode, converted and available as this. And second thing is basically, for example, if you want to find out the ASCII representation or Unicode representation of this particular website, iiref.bharat, you can find out the ASCII representation. So this is something which is already there. One second. So here you can see this iref.bharat. So this domain name actually shows there in that, and similarly in multiple languages also, Tamil also it is there, Sanskrit also is there, and domain name you can directly type it. So we have a number of contents which is actually available on this entire part on DNS. So you can youtube.com/@ in green. So this is one of the things you can actually look at it. So this is what I talked about. So we'll be discussing more on this particular part. So thanks for your patient listening. Yeah, but definitely presentation will be shared. And yeah, what do you mean by DNS poison? Means basically someone changes the entries there, records, or what I can say records. Actually, somebody, somebody in the sense through malicious program, they change the this thing. So, for example, you type codnsec.in, you always end up in somebody's Wells web page. So that actually is called a poisoning. Okay, so xyz.com, what is the second level thing? So here, if you're talking at dot is the root server, TLD is .com, something else becomes your second level domain. Presentation will be shared, definitely, yes. Yeah, in this one, actually, you can see our previous training programs also. You can see all the presentations which is also being shared. It will be done. Is there an API access to it? Access for it? Yes, we have. I think you are asking for malicious domain service. Yes, we have API-based access for malicious domains that is available. Okay, so that depends on which DNS server resolver is best. So we look at bind. We have been working on bind, and of course unbound is also there, but large majority of the people use bind. So it's open source and everything is good. Is there any mechanism available for maintaining genuinity of authorization where records are? That is where DNSSEC comes in. So the DNSSEC actually looks at it. DNS poisoning definitely will be elaborated in the upcoming sessions. So thanks for listening.